Hey guys, welcome back to Data Science Sessions episode 5. My name is Ariston, and I'm the host of this YouTube channel, and this is a series where I do data science. Well, at the moment, working on data analysis still, but yep, at the beginning of these videos, I usually, in this series in particular, I talk about one thing that I'm working on, so, like self-improvement and stuff. So let's go to that. These are the Goofy Goobers, SpongeBob, Patrick, and the Goofy Goober. Um, yeah, one thing that I'm working on is acknowledging that I could be wrong, you could be wrong, we could be wrong, um, all the time. Even if, you know, you feel like you've been right all your life about a certain thing, you might be wrong. And the chances of you being wrong are never zero. So, you know, the chances of anything happening tomorrow are never zero. It could be the first time, it could have happened in the past outside of your knowledge, but the chances of you being wrong, like that is such a normal everyday event that you'd be foolish, and I'd be foolish as well, to think that you couldn't be wrong about something. And, you know, it's because our emotions get involved and our pride, and we build up this ego. So we just refuse to think like, oh, how could he be right about this exercise or this topic or these politics. Anyways, I'm not gonna go on the tangent, but yeah, always acknowledge that you could be wrong in any given scenario. That should cross your mind at least once. At least once, at least let that cross your mind. Anyways, let's go and yeah, 2 minutes. Uh, yep. I haven't uploaded yesterday, but no stress because I yeah, just didn't feel like it.
Welcome to the first week of Data Ecosystem.
With that said, like I'm on summer break and my routine the past week specifically has been really bad. I've been sleeping late. Like today I slept at like 2:30 a.m. and then I woke up at 8, drove 40 minutes to go see my physiotherapist and a bunch of things. So tonight need to lock in, need to get back on track, make the videos. If I can, pump out a second video every day.
Course
But
of
yeah,
Tableau Business Intelligence Analyst Professional Certificate.
last time, 2 days ago or a couple days ago, we finished all of the frickin' logistics and big picture view of what business intelligence is, and now we're moving on to the actual learning about the data, which, tabular data, spreadsheets, how databases work. I already know that stuff, but I'm going to go through these things anyways with you guys, so I can, give myself a refresher. And also, you learn by teaching, you learn by explaining. Feynman technique, look it up. Um, and I think, yeah, okay.
Hello again, Sean here. As the name suggests, the
So,
focus of this course will be on data, where it's stored, how to access it, and how to manage it. As a business intelligence analyst, a large part of your job will be centered around data, gathering it, analyzing it, interpreting it, communicating it, and using it to make decisions and recommendations.
yeah.
So having a firm foundation and understanding of the data ecosystem is a critical step to becoming a successful business intelligence analyst. This week you'll learn more about data sources. You'll learn about spreadsheets and databases.
Okay, course 3 has 3 weeks. We have this stuff, and then this stuff. So, it looks pretty good.
And the
Just
differences
talking
between
about
them.
data.
You'll also dive into the concept of database management. By learning about tabular data, spreadsheets, and database management systems, you'll be laying a good foundation for your career as a business intelligence analyst. Okay, let's dive in.
And it is so important. Okay, let me read this first. I'll hold on to my thoughts. Okay. Data can be structured, meaning organized in many different ways. One of the most common structures for a data set is tabular, meaning the data is organized in a table format. Yep, so if you've ever seen an Excel spreadsheet, that is pretty much what tabular implies. So you have cells, you have columns, you have rows, and you organize it a certain way so that it's efficient in the way you log down data. Like you wouldn't just put Monday here and then Tuesday over there and Thursday over there. You put them all at the top, and then you put these different attributes, you could call them, on the left-hand side. So yeah, and pretty much everything, how data is stored, 99% of the time, it's gonna be in some kind of like format like this, even if you can't see it. Okay. Uh, is it obvious already? Okay, all of the data is tabular. Okay, let's move on. Spreadsheet software. Okay, and then with spreadsheets, hmm. Spreadsheets, we got Excel, we got Google Sheets. Yeah, but then there are more spreadsheet software options out there. Google Sheets is recommended for students in this course because it is easy to access and free to use. Most examples and screenshot captures in this course will use Google Sheets. It's not, well, I'm not super good at either or. I've done papers with Excel, but I personally use Google Sheets just because I feel like the layout is funner and more, I guess, modern. Anatomy of a spreadsheet. Okay, I'm just gonna skip through this, but you got your cells, you got your tables. I mean, not tables. You got your cells, uh, you got your rows, and you got your like columns. Damn it, I said like. I should pull out the sticky notes. Let's see how many times I swear and say like. Uh, okay, let's make this one. Hmm. What color? Blue. Like counter. Swear counter. Okay.
Spreadsheets are electronic documents used for organizing and analyzing data in different ways. Sheets can be accessed by the tabs on the bottom. For
Yep.
now,
We're just talking about
cell,
basic
for instance,
stuff.
is in columns can be expressed range containing this group of sheets, cells, rows, and columns.
Oh, I guess you can also say range, yeah. A range is basically it's like it's like a subset of cells. Yep. Okay. They aren't just for storing your data. You can manipulate and analyze the data. It just means you can like edit it, remove. Uh, yep. I'm trying to remember. There's a specific term for tools like SQL and spreadsheets. It's data. No, data editing tools. Data storing, anything, tools, acronym. Eh, CRUD. There, that's the thing. Create, read, update, and delete. So you can create data. You can, create, read data, update, and delete data into, out of, inside a spreadsheet or a database. Create visualizations. Yep, you can do that with Excel as well, and it integrates with Tableau. Oh, I just realized they're they're using Google Sheets because Excel is like the rival company. Oh, I said like that last one doesn't count. One, two. A spreadsheet, a database. What are the two most commonly used spreadsheet software programs? Okay, Sheets, Excel. What are the two most commonly used spreadsheet software? What? Microsoft Excel and Google Sheets. What are some of the standard structures of a spreadsheet? Range, cell, column, row. Which column contains the total landfill amounts? E. What is the selected range? This is B2 to E16. In addition to storing data, what are the three other ways in which business analysts can use spreadsheet? So CRUD, create, read, upload. Is it upload? Delete. So it'd be create, upload, and delete. Submit. Hmm. Yep. What is a database? Okay, so yep, let's go through this. So we have spreadsheets, we have databases. If you're a data analyst, you're for like a small company, you're not gonna have a database unless your boss was smart enough to actually hire like ah I said it again. Unless your boss was smart enough to hire an IT department and set up a data warehouse and data infrastructure. Um, Databases are like spreadsheets on steroids. They're like way faster than spreadsheets. They can manage way more data. Um, they're just, they're a lot more dynamic. So companies like Amazon, YouTube, Facebook, for the amount of traffic that they have and the amount of data that flows through their, businesses, they need lots and lots of data warehouses, databases all around the world, backups and whatnot. Spreadsheet storage would definitely not work for these companies. Yep. While there are many data storage options, the most popular method is in databases. Yeah, and then it says here companies of all sizes have databases. Um, mhm, mhm, mhm. Allows analysts and other data professionals to access the data they need without storing files locally on their own computers. As you saw above, a database is an organized collection of information referred to as a storage container for data. And then we have two kinds of databases, relational databases and non-relational databases. In a relational database, I've studied this, in should I think I should be penalized for using the phrase, Yeah, the one. A relational database has entities, and these entities are like spreadsheets. I think it's okay that I used the word like there, so I won't penalize myself. But the entities have attributes, and these attributes are related to other entities. So you might have something such as, see, I didn't say like there, such as a customer entity and a orders entity, right? In in a spreadsheet, it might look like you have one spreadsheet which just says no. One spreadsheet just for the customers, and in the customers you have the name, you have their each row of customer has or each customer has a customer ID, a customer name, customer age, these things. And then in the orders table or the orders spreadsheet, you can think of it as there's a separate row for each order, and then the attributes might be like the items, the quantity of the items, the tax, the category, these attributes, but then you're also gonna have the customer ID in the um, order order attribute. So because you need to, track. Oh my God, I'm waffling. But anyways, we'll get to it. Hopefully you got what I mean. If you didn't, then I'm sorry. Not sorry. What does the database look like? Physical drive. Yep. Cloud storage. And this is just saying this is what a database used to look like, or maybe it still does. Networks of servers that can be accessed by data professionals through programming like just like SQL. Yep. And with databases, these are the three main benefits. Security is one, because with a spreadsheet, there are a lot less tools and features you have at your disposal to prevent things like data deletion and people messing with your data. Whereas with a database, you can set up rules, you can set up uh, um, preventative measures from destroying or editing or I guess updating data if you don't have credentials or whatnot. Yeah. And then it says here you might have to work with data that has millions or even billions of rows. Yep. There's not much that can be done to prevent someone from entering incorrect information. A relational database allows you to set rules and restrictions. Yeah, mentioned this. Yeah, so they're both tabular. They can database does large. Uh, SQL is used to communicate with databases specifically. Google Sheets is a spreadsheet. Um, rules for the format of data. Again, uh, database. So what I mean by rules for the format of data is that on a spreadsheet, you can just click on any cell and start typing away. But you can't do that with a database because if you try to do that and you input a string instead of a float or a number instead of a string, then you just get like denied instantly because there are rules set up. Maybe. Small to medium data sets. They both have filtering, they both have ordering. Databases have restricted access, and then spreadsheet, anyone can enter the data in any form. Next. College data, empty data, college database. Yep. Practice assignment. Okay. My throat is kind of a bit tender right now because I've been practicing my metal screams these past couple days and the grit and the distortion stuff and yeah. So trying not to strain at shooting this video because I really want to shoot a video. That's partially why I didn't shoot yesterday because I was tired. My voice was messed up. Like it doesn't hurt. It doesn't sound like there's something like bad, but there's like this one little spot in the back of my throat, which I feel when I do, oh my God, voice crack. When I do screams and stuff, but not when I talk regularly. What are some reasons that it would be beneficial for companies? Okay, so security reasons, quality. Let's just do three. Rule of three: security, quality, and accessibility reasons. So security, you got the rules. It's harder to jump the fence and start making changes to the data, and then the quality will keep, you know, poor. How would I say this? The rules are a security feature and a quality feature. A quality feature because they control the data types of the inputs going through and being stored in the tables in the database. So that's why quality. And then accessibility, spreadsheets don't communicate nearly as fast as cloud databases. At least for big data. What is the difference between a relational database and a non-relational database? Entities in a relational database have may relate to one another via keys, whereas a non-relational is like a mixed bag of different foods. How are relational databases and spreadsheets similar? Okay, let's go top to bottom. Save information, access at a later time. Yep. Rows and columns. It's not called rows and columns in a relational database, but that's basically what they are. Filter data. Yep. Both store practically limitless. Nope. Spreadsheets top out at like 8 billion, I think. Or maybe less. I feel like my voice is changing so much from all the talking and hearing back of my voice that I've been doing.
Hi, my
Ungraded plugin.
name's Taylor and I'm going to give you a high-level overview of database architecture. Understanding the big picture and principles of database management. So let's see your open of information surrounding your system. Maybe it looked like, and you just record this information for each of your customers that trickle in. Bigger place to have room for all their values for your customer's address.
I need
Mary
to
calls
speed
to
it up
ask
because I
about one
might
of her
get
orders. And when you
copyright
pull up
stricken. I think that's how it works.
her information, you get 3 different addresses, all these disorganized
Boom,
orders, and you're
nice.
not even to the wrong place. Customers might get mixed up, and different bite-sized tables. So
Okay, so database tutorial, and then he talks about different tables, right? And this is what I was trying to explain a while ago. It's hard without any visuals. I should probably open spreadsheets to be honest, but I'm not sure if we're gonna use it again later. But this looks like a spreadsheet that has several columns of which the attributes of a customer can be kept track of. So for example, this bottommost customer, Ann Lake, we got her address, we got her customer ID, we got her phone. So this is good because now we have this customer entity, this customer table, which just has a bunch of customers in your database, you know.
unconsolidated.
Ah, I said it. No.
Place.
At least I haven't
The
said the
product table
L
would have
word. And then you have this product table. Okay. You got your products, you got their product IDs, quantity, price, etc., whatever.
all your cat accessory inventory as you add another. We'll start in the custom.
And then you have an order table which collects and basically takes some of the data from some of the other tables. These are known as foreign keys, and it uses that to fill out the order entity. So orders have products, right? They also have customers, And this is really efficient because it mitigates data duplication. In computer science, it would kind of be like there's only one instance of the data in the memory, and we are just pointing there instead of having multiple copies of the data in the register.
Table. Checked out, he entered all his contact info, and we
And
recorded
that's
it
why
in
it's
his customer
fast.
table and assigned him a customer ID.
It might sound kind of trivial, but when you're working with, 10 billion data points, 10 billion rows, 10 billion is way less than 50 billion, 100 billion.
Let's move over to the product table. This lists all our inventory, and here's the cat costume he wanted. We keep track of it with a few fields here, like product ID, quantity in stock, and pulled in the customer ID from the customer table, so we know it's Ronald. We also pulled in the product ID from the product table, so we know that he purchased this cat costume. And there's other data in here that tells us about the date of the sale, shipping address, quantity, etc. It's pretty obvious that this system we're using now is far more organized than the specific product ID and his customer ID.
And this is what an ERD looks like, an entity relationship diagram, right? Okay, I can't full screen. Cool. Yeah.
Those are visualized through predicate through they can start deeping. The diagram concept thing works.
And then you have this crow's feet diagram. It's called crow's feet because of these little like forks. Ha, damn. Use the L word again. At least I haven't sworn. Yeah, that's chill. Database management. I reckon that's a pretty good role, especially if your company really relies heavily on like a well-maintained database. Yep. What is an relational database management system? We got things like, I think, MySQL, Postgres, BigQuery, RDBMS examples. Yep. It's a database management system. Only allows for tabular data. Oh, is that the answer? So the difference between a relational and a non-relational database is that relational databases are strictly tabular. I guess that makes sense because how would you relate a table to a graph or a chart or a text document? Reading MySQL. This is the dolphin. That sounds really funny with no context, but they have a dolphin as their icon. The chart below illustrates the most popular database techniques. Okay, let me just check the time, guys. This course won't go into the specifics of SQL, but it's important to be aware that this is the primary language used to retrieve data from a RDBMS. I need to work on my SQL, not my SQL, but my SQL. Database management, yeah. "28 minutes." Because if you work for a big company, that's the first thing they're going to look at, right? They might not care too much about your spreadsheet skills if you're barely going to be touching them because you're only communicating with big data. True or false? Database management is the maintenance of information stored in a computer system. In a computer system? That sounds very generic. Is the maintenance. Yeah, let's just say yeah. According to this, what feature of element forms the database and makes it distinct from a spreadsheet? Connections between the various tables or spreadsheets of information. What is the difference between a database and a DBMS? A database is the silo. Are the set of tools used to maintain the silo. Maintain and modify the silo. A silo is just like, another one bites the dust. Ah. What are the three distinctive features of a database management system? Yeah. Upload, modify, delete data, I'm gonna say. Or I think it has to do with setting rules and data storage, retrieval, and modification. Upload, modify, delete. Upload, modify, okay, retrieval. I suppose um, deletion is part of modification, so fair enough. What is the biggest difference between a DBMS and a relational database management system? Something about tabular. Uh, the form of the data that is allowed by the databases. So a relational database is purely tabular. What is MySQL? It's the SQL. It's a relational database management system with a dolphin logo. It's pretty good. Next, data storage and management. Let's not read through this because it's just these sections are like filler segments in an anime or a show. They're not canon. They're not gonna, help you beat the final boss. I said, again. Golly. Ask a probing question. Participation is hold. Week 1 recap. We talked about database, we talked about database management, relational database versus non-relational databases. Yep. SQL, some stuff. Data sources. Okay. 3245. Okay. Which of the following are examples of tabular data? Be this and this. Which of the following is an example of software that typically contains tabular data? Sheets, Excel. Anatomy, a spreadsheet. Which of the following are structures within a spreadsheet? Columns, rows, cells, and neither of these are structures within a spreadsheet, I believe. Sheets maybe? I'm pretty sure it was ranges, but yeah. In the image above, which spreadsheet structure is shown in the red box? A row, horizontal. In addition to storing data, spreadsheets can be used for which of the following purposes? Visualizations, business decisions, manipulating data. Yep, all of them. Which of the following are features that databases and spreadsheets have in common? Save information, store data in rows and columns. Databases and spreadsheets have security features that can restrict access to certain columns of data or prevent individual users from deleting tables. I must say, I must say that that is true. Does Excel have security features to prevent modifying data? You can lock the cells. Okay, so technically the answer should be yes, right? Both databases and spreadsheets have security features. Yep. Both databases and spreadsheets can filter for, yep. It hurts when I burp. Hopefully my vocal cords aren't exploded. Primary purpose for a company or organization to use a database to store information. Um, it's this one. I read the other two and they don't really make sense. You can pause the video. What is database management? It's the maintenance of data in a computer system. True or false, a database and a database? No. One is the silo, one is the tools to maintain the silo. The biggest difference between a DBMS and a relational database management system is the format. True. In a non-relational database management system, you have a bunch of stuff like spreadsheets, tables. You have tables, you have graphs, you have text, documents, images. So not that. Cool. What was my wrong answer? Week 2. Time check. 36:25. Let me pause the video, guys. I'll be back. I just need to quickly go to the gym because I'm trialing out the new gym and brokey. And I can only come in during the staffed hours. So it is 6:07, so I need to go now because I'll have less than an hour to get in before then. So be right back. When I get back, I'll have a nice cold shower, continue go hard with the data analysis, and we'll continue from there. We are back, from the training and stuff. Just got home, had a meal, and we are back into week 2. Okay.
Welcome to the second week of the Data Ecosystem course. Hi everyone,
Yep,
Sean here.
let's see what we are going to
Last week we
do
learned a lot about data
here.
sources.
Data warehouse, data lakes. I assume what that means is we are going to talk about the actual, maybe hardware, the software, data warehouse, data lakes. Okay.
You learned about tabular data, but what happens when a company or an organization collects so much data to the point where a database simply is not enough?
A database is not enough, okay. I guess a collection of databases is a data warehouse, and perhaps a data lake is a more free, like quote unquote free data storage. There isn't as much restriction, maybe.
This is where data warehousing, the focus of this week, comes into play. By digging further into the data ecosystem, you'll continue to build your knowledge and understanding of data in the way it's gathered, stored, accessed, and then eventually analyzed, interpreted, and communicated.
Okay, data warehouse video.
Data warehousing is one of the hottest. Wondering what it, because in 4 minutes you'll start with the
This is a
definition.
YouTube video, so I don't want to get
data in one place on a file.
copyright
Once
claim.
you are done,
We're just gonna
final,
tab through them.
final.
Okay, final. Nope.
Never know where the most recent or most appropriate file is for an
The data warehouse is the single source of data truth.
organization. It is
Sounds
integrated,
kind of weird.
time variant, non-volatile.
Okay.
Therefore, it does not contain all company data ever, but
Okay.
only the subject matters of interest. For instance, data on your competitors need not appear in a data warehouse.
Competitor data. I've never really thought about that, but I guess if, competition is high, then you'd want to try what you can to leverage the publicly available data from other companies so that you can use it to strategize against them.
However, your own sales data will most certainly be there.
Okay.
Each dimensions from everywhere
Integrated.
to that like button and
Okay.
share it with your.
So what it seems like is a data warehouse is
single source of truth. Practice a very simple example.
why do they use these obscure definitions instead of the literal definitions, like single source of truth? If I just said single source of truth, no data scientist would give me the no one would say, "Oh, you're talking about a data warehouse, aren't you?" Like, silly. Okay. Let's see here. Okay, headers, data warehouse, feature database, data warehouse, online analytical processing. When it comes to data storage, data warehouse is a system that combines from multiple sources across an organization. That's fair. Okay. Customer data. Okay, so on the website, on the phones, other this might be a database. That's a database cylinder. Data analysis, data sources, data warehouse. Okay. Can contain historical data from 5, 10, or even 15. That's arbitrary. Don't have to mention that. And that data is usually cleaned and condensed to make large queries fast and accurate. Okay. Single source of truth when analysts create reports and make data-driven decisions. Because data warehouses are larger and more complicated than databases, they sometimes require more complex queries, and thus fewer concurrent users may use them when compared to a database. Often be the analyst's job to design queries to pull the right data from a warehouse into analysis software like Tableau. Okay. Timeline, database is real-time current data, data warehouse, historical data. I guess that makes sense because a warehouse is usually where you put the old stock or old things. Okay. Normalized, denormalized, connected tables are combined into one large table. Okay. Designed to update the table data quickly. Designed to query and extract requested data quickly using online OLAP. Okay. That gets and processes information from a database very quickly. Online analytical processing. Okay. OLAP and data modeling concepts. Ungraded plugin. Okay, again, we might get demonetized, so we gotta like zoom through it just a bit.
Welcome to this
Not demonetized, copyright
Capital
stricken.
Advisors video on OLAP and data modeling concepts. It is an approach to analyzing data from measures and cubes.
Dimensions, measures, cubes. A cube is a multi-dimensional data set, time, regions, products. Okay.
Cubes.
That is interesting. Okay, multi-dimensional data set. Doesn't that just mean it has multiple, at least 3 attributes?
Can
Is time an attribute, region an attribute, or are these entities?
hold data, collect related items, such as products, time, or regions.
Okay, and dimensions are lists of related items. Okay.
2 dimensions. These dimensions
Okay, and product, time, regions, those are entities.
can be combined into cubes. If we add data to can be any quantity or dimension, regions, then you can imagine each region being represented, adding the third dimensional set. So what's the value of using OLAP? To illustrate this, let's say that your products that appear to them with the same number of items for each product, quarter, and region. 2 dimensions. Here we have a 2-dimensional report that looks at units sold by product and by quarter. See that product D does better in the first quarter, product C in the second quarter, and product B in the third quarter. Now, we can see that in the West, only product D is south, product C information. You would probably make very different decisions than you would looking at a report with just 1 or 2 dimensions.
Yeah, that makes sense. Okay, so this is 3 dimensions because this is kind of like a, what kind of segmented bar plot, or maybe a mosaic plot in our speedrunning math. Mosaic plot. Or, wait, it's called a conditional, nah. What is it called? What is it called? It's not a mosaic plot. It's a conditional distribution or something. Conditional distribution bar plot. Yeah, okay. It is a conditional distribution. These are like, I said like, these are the categories. And they have subcategories and they're repeating.
If I pose a row dimension better now, or you can reach me directly at.
It says in practice, and then it's exactly what it was in theory. Okay. Okay, and then this compares databases versus data warehouses. Databases focus on data in, data warehouses information out. User-facing applications, internal tool for various stakeholders to make data-driven decisions. Data is updated regularly. Data is rarely updated. New data is added but does not replace old data. Up-to-date historical data, structured to reduce as much duplication. This is called normalization. Data is grouped and includes redundancies for the sake of improving the ability to read data. Okay. Data warehouse basics assignment practice. Okay, 47, 35. I should have bought some lozenges. In your own words, what is the data warehouse? A data warehouse is a collection of denormalized historical data. It is used to make bigger data decisions. OLAP. What are the 3 key differences between a database, data warehouse? Historical data versus real-time data. Focused on insights out rather than data in. Denormalized data. And let's see, what else? Oh, I thought it was data warehouse first, but flip it around. Denormalized data. Bigger versus smaller. Which of the following is true about a data warehouse? Select all that apply. Data can only come from a single source. Nope. The information in a data warehouse is related to a single subject. I'm pretty sure that's true. Consider the single source of data truth. Data within a data warehouse cannot be changed or deleted. Now that's stupid. Like, of course it can be deleted, just isn't. But if I get enough wrongs there, then I won't pass this. So, let's see. Damn. Ah, crunchy. Ah, this is the thing I was thinking above. Extract, transform, and load tools. Yep. You extract the data, you transform it, then you put it into the warehouse. I mumbled a lot there. Extract. In this step, data is extracted from a variety of sources, like this, Ads Manager, Google Analytics, Salesforce. Extraction process involves querying the databases, sometimes at regular intervals, to get similar data together so it can be combined. For example, you might want to extract all the sales transactions from both a store and a website for the last week, all the new customers from the last week, and all the new leads from the last week. Okay. Once all of the data has made its way to the staging area, it needs to be transformed in singular format. Combining data from multiple data sets, filtering, sorting, aggregating, summarizing, removing duplicates. Basically, you're readying it up, making it clean, as clean as you can at least. Once the data has been extracted and transformed, it's ready to be loaded into the data warehouse. How often data is loaded will vary based on the strategy and systems a particular organization uses for ETL. This three-step process helps prepare data for quicker access and therefore quicker insights. I think that's pretty straightforward. ETL drag and drop activity. Okay. Okay, so we collect from sources, then we clean it, then we put it in the warehouse. Check. Easy. Data warehouse walkthrough. In reality, a college often utilizes a number of subsystems for data collection and storage. Yeah, makes sense. Student registration, course management, accounting, payroll, marketing, analytics. Yeah, think about it, guys. I said I'm pretty sure that's a banned phrase, banned word. As a guy that likes computer science, I like to think. I'm very curious nowadays. I wasn't always like this, but don't be lazy about your curiosity. Think about your phone. How does it gather data? How do ads work? How do they know what ads to show you? How does your Tesla car, know where to drive, how to navigate traffic? How does Google Maps tell you where to go? Should you take a left turn now or not in 100 meters? Think about all of these things. How does a vending machine, I said it again. How does a vending machine accept your payment, clear it, and then give you the soda? And how does the money go from your bank account to the other bank account? How, No, I said it again. But my point is, if you think about this stuff more, things will make sense more. So be curious and assume things and hypothesize things and look them up and think really hard. It's really enjoyable to gain clarity in these things. I was about to say the why, the banned phrase again, but I stopped myself. Collection and extraction. Okay, so we have a bunch of different databases here. The payroll database, accounting database, course, student registrar, marketing analytics. Okay. Staging area, removing tables. Okay. So we're removing tables, we're merging tables. Creating and calculating new columns, which might provide additional information. Removing columns, just like removing entire tables, you can also remove columns that are unnecessary for analysis. Loading the data warehouse. Once this is done, college can use tools like Tableau to connect to the data warehouse and start discovering patterns, trends. Okay. I think that's quite straightforward as well. Data marts. Thus far, you've seen two ways in which data warehouses can be organized. The basic data warehouse, where data is loaded directly into the warehouse from various data sources. A data warehouse with a staging area, where data is extracted from the various sources. Okay. What is a staging area? A staging area, it's just the steps you do, the ETL, the pre-processing before storing it into the data warehouse. Okay. Data marts. Segment of data focused on a particular business domain or department. Might have data marts for departments like finance, marketing, sales. Functionally a data warehouse, it is formatted and accessed the same way, and the source of data is often a larger data warehouse. Data warehouses, data marts are created and hosted on the same types of software applications. Then the data, and then the data, and then the data. I'm saying that really weird. And then the data is extracted and analyzed with tools like Tableau. Help to streamline the analysis process by directly delivering the data that is most relevant to each team. Some of the benefits of using data marts include simplifying access to data. Because teams are only accessing data relevant to their department. Yep, that makes sense. That makes sense because why would you... So a mart is basically like a mini data warehouse. Where does it say? Wait, where did I read that? I'm pretty sure. Oh, yeah, functionally a data warehouse. Each team only needs to access a segment. Yep. So it's a segment of a data warehouse. It's like a smaller data warehouse. Yep. Easier data maintenance. Each team controls their data, making it easier to maintain. Yeah, imagine a big warehouse. Warehouse. Imagine a big warehouse and you divide it into different different segments. And you just get different teams looking after each segment. And if anything is wrong, if anything needs maintenance, then you look at the different teams and they're responsible. Pretty good, if you ask me. Less expensive. Much more cost efficient than an enterprise data warehouse. Yep. Dependent, independent, hybrid. Okay. Top-down approach to data marts. To create this type of data mart, a segment of the data is related to a specific domain. Transform loaded into data mart. Independent. Created directly from internal and external data sources. It does not require a data warehouse. Can be inexpensive and easy to get up and running. For example, so that you can make... Okay. By pulling external data on social media trends to compare it with your own marketing data on the same trends. So that you can make predictions about future trends that you can capitalize on. However, without data warehouse, each individual mart will require its own ETL process. Can be difficult to manage. Hybrid data mart, it has both functionalities. Okay. Data warehouse. Time check. 1 hour exactly. Wow. Start. What is the name of the stage in which data is taken from a variety of sources? Extract. What is the name of the stage in which data is changed into a singular format that best serves the business needs? Transform. What is the name of the stage in which data is placed into the data warehouse? Load. That's the last step. During ETL, when data is in the staging area, which of the following steps might be taken to clean and transform the data? Hmm. Taken to clean and transform the data. Yeah. I need to read that again. I haven't read it properly, haven't processed it. When data is in the staging area, which of the following steps might be taken to clean and transform the data? Select all that apply. Okay, so what are the steps involved? Removing tables that are not relevant, removing columns are not relevant, maybe merging them if they can be merged, and then you might make new attributes or columns. How is a dependent data mart created? Pulling data directly from internal and external. Oh, no, no. Segmenting, combining data from an existing. I'll go with the second option, but I'm not 100% sure. I didn't read internal data sources a while ago, so I might be wrong. How is an independent data mart created? Dependent data mart, okay. Segmenting. Pulling the data directly by segmenting and pulling data directly from internal, external data sources. Let's see. If I get them wrong, then gotta do it again. Nope, got it right. What is a data lake? A repository that allows you to store all your data regardless how it is structured. It allows you to store your data as is. Okay. Who is credited with naming the concept of a data lake? Okay. Repository that allows you to store all your data regardless of how it is structured. Okay. This is pretty cool. So we have lakes, warehouses, and marts. And the comparison is to that of a bottle of water. And a data warehouse is a pack of water bottles. And a data lake is just water. Yeah, I like that. Traditionally, business analytics have been focused on collecting and analyzing data from a few key systems like customer relationship management systems or purchase records. But, okay, this can include things like transcripts from a recorded call, data generated from sensors in your smartwatch. This is known as big data. A data lake is typically used as a place to store data whose business value is not yet known. This data can be stored in its initial state in a data lake until it's ready to be used. At that point, the data can be processed, restructured for analysis. Why do data lakes matter? Data lakes allow you to collect any and all data before you determine what to do with it. This allows you to remove some of the business logic from the data collection process. Just because you don't know what to do with a piece of data now doesn't mean you won't want to use it in the future. The data lake gives you a sort of universal access to any data from any time in any format. To better understand just what a data lake is, continue to the next lesson and watch a short video. Yeah.
When choosing between data warehouses and data lakes, Data warehouses and data lakes are both data repositories designed for housing vast amounts of data. But which one best fits your needs? Sources, like transactional systems, operational types. Data warehouses store structured, processed data from a few specific sources.
Okay, so the main difference is structured versus unstructured data, right?
Like transactional systems, operational databases, and applications.
I'm trying to think. I don't want to get the cop-out answer. But I assume that the benefit of going with data lakes over data warehouses is that perhaps it's more efficient, perhaps there are scenarios wherein you would rather have the raw data, because when you have databases and you have data warehouses, you have intermediary steps in between, oh no, I said like curses. You process the data similar to how when you shoot video on a camera or a photo, there's compression taking place, so you're not actually getting 100% of the information. You're getting a lot of it, but depending on the kind of quote-unquote compression, you are going to lose a bunch and get a bunch of artifacts and side effects. So it's the same thing with data warehousing, database, loading data into a database. Data lakes store the raw information, whereas databases and data warehouses already process the
Data lakes
data.
store both structured and unstructured data from more sources, including sensors, intelligence, batch reporting, and data visualization, well suited for users with limited technical knowledge. For machine learning, predictive analytics, and data discovery. For machine learning, predictive analytics, and data lakes store big data analytics.
Yeah, so big data, step counts, GPS, sensor data, what other things? Coordinates, brain cell activity, neuron activity, electrical data.
Analytics. For machine learning, the link above or in the comments below will relate data warehouses and lakes use denormalized schemas. However, warehouses use schema on write, while lakes use schema on read.
Schema on write. So warehouses. What is a schema? A schema is a certain structure that a database has to follow. On write, on read. Let's see
Schema on
what
write
she
is a traditional
says.
one-size-fits-all approach, but data being shared more and more between people with different roles and interests, more emphasis is being placed on the more flexible schema on read.
What is schema on read? She didn't explain. I wonder if it's important. Data warehouse stores, okay, retain data in its native format.
Curated data. Centralized may not be.
Okay, pretty straightforward. A bit obscure, but we'll figure it out. Okay, let's talk through this. Data warehouse, data lake. Purpose, data types, data capturing, data normalization, benefits. Structured, processed data. Raw, structured, unstructured. Storing data that is ready for business analysis and visualization. Storing big data for machine learning, predictive analytics. Better suited for data analytics experts and data scientists. Makes sense. Capture data from, yeah, so here's an example, okay? Data lake versus data warehouse. What do you think requires more statistical expertise? Doing statistical analysis for a clothing brand to forecast sales and do descriptive statistics, or to get the freaking GPS data from Google and do stuff with it. Obviously, the GPS stuff is like, more obscure and more cryptic, hence why it's so scary, but that is big data. Okay. Data is structured before being loaded to the database, only structured when it's ready to be read and analyzed. Ah, okay. Schema to read, schema to write. So the difference between a warehouse and a lake is a data warehouse is schema to read, schema to write. So it gets structured, it gets processed as it is loaded into the warehouse, whereas with a data lake, it's only structured when it's being read. So when you retrieve the data and retrieve it for analysis, that's when it becomes structured. Pretty cool. I think that's what it means. Store historical data with accessibility in mind. Store data in its native format with flexibility in mind. Contain curated data ready for immediate analysis. Contains raw data that may or may not be ready for immediate analysis. Okay. Data lakes practice assignment. Data lake practice 111. Start. A data lake is a data storage structure that houses raw, unstructured, structured data. Which of the following types of data can be stored in a data lake? I mean, I don't see why not all of them, right? Transcripts from a recorded call, information stored in a database, PDF copies of contracts. Wouldn't it just be all? A data warehouse captures data from a single source, whereas a data lake can capture data from multiple sources. True, false. They can both take multiple sources. Which of the following is true about data lake? Select all that apply. Only structured when it is ready to be read and analyzed. Yes. Ease of accessibility. No. Native format with flexibility. Yep. Okay. Let's go with this. Let's see how we do. Yeah. Week 2 recap. We did a bunch of stuff. Talked about warehouses, lakes, databases, ETL. Yep. Okay. Data warehousing. $113. 30. What is the most efficient way to analyze all of the data that has been collected in these separate databases? I would say load the data into a data warehouse and then conduct the analysis. Create separate reports from each database. Combine the separate databases into one large database and then conduct the analysis. That might be the answer because it's quite fast, but it sounds a bit silly. But that might actually be the answer because a data warehouse. What is the best, most efficient way to analyze all of the data that has been collected in these separate databases? A data warehouse would be slower than just having one database for analysis. Okay, we'll come back to that. A database typically contains data from multiple sources, whereas A data warehouse, data from a single application. False. A database is optimized for the collection and storage of data from a single source, whereas a data warehouse is optimized for the storage and analysis of data collected from multiple sources. True. What does ETL stand for? Extract, transform, and load. In which stage is data placed into the data warehouse? Load. Which of the following is a type of data mart? Hybrid, dependent, independent. Which type of data mart is created directly from internal and external data sources without a data warehouse? Independent. What is the primary reason that a company would choose to utilize a data lake? Allows for the storage of all types of data. A data warehouse contains curated data that is ready for immediate analysis, while a data lake can contain raw data that may or may not be ready for immediate analysis. True. Which of the following features accurately describes a data warehouse? Select all that apply. Historical data. Yep. That is ready for business analysis and visualization. Yep. Includes both structured and unstructured data from many sources. No, that is a data lake. Okay, let's go back. Combine the separate databases into one large database and then conduct the analysis. I'll say load the data into a data warehouse because as you load it into the warehouse, you do the cleaning things and you might have to, you might want to, you might choose to, you might need to leverage data that is in the data warehouse and not those databases. Okay. You're ahead of the game. And I failed. Nope, 100%. Okay. Welcome to week 3. Okay, let's start week 3, I guess. Going pretty smooth. Week 3 start. Okay. Course wrap up. This is the last week on module 3, and then hopefully we get to do some Tableau. We will sail through this.
Welcome to the third and final week of the Data Ecosystem course, the third course in the Tableau Business Intelligence Analyst Professional Certificate.
If you guys choose to do this course, I would say so far I recommend it. It is a bit slow for me, and it is very, catching myself is really funny. It's pretty good if you're new to data analytics. I'm a data science major. I'm a data science major, minoring in data analytics for business. So a lot of these concepts I've already heard of. That's why I'm breezing through. If you need some time to do the assignments and quizzes, and you need to study a bit more, that's understandable. Don't feel bad if you're not breezing through it as fast as I am. But yeah, keep at it.
So far,
The first time I did the data analytics certificate, it took me maybe 3-4 months to complete, and I was doing it every day, but some of the assignments were kind of hard. I had to go back and review a bit more.
Of course, you've learned a lot about data, particularly where and how it's stored and how to access it. You've learned about
Okay, we're going to learn about data quality, data governance, and architecture.
spreadsheets and databases, database management systems, data warehouses, and data lakes. So at this point, you might be wondering how an organization is able to ensure that all this data is accessible throughout the organization while also maintaining security of that data at the same time. And that's going to be the focus of this week's lessons, data management.
Yep.
Data management can be thought of as the logistics of data, how you collect, store, validate, protect, and maintain.
Okay, data management, logistics of data. collecting, storing, validating. Validating data just means that you're taking steps. These are the steps involved in making sure that your data is valid. And when we say valid, I'm talking about the format, I'm talking about the data type, I'm talking about following rules so that if someone is asked for their birthday, they can't give you text, they can't give you letters, they have to give you a date. They can't give you just random numbers either, it has to be a date. Also, I paused the video at a really funny moment. Look at his face. Underbite. I used to have an underbite. My God.
So this week you'll dive into a few of the key components of good data management, including data quality management,
Yeah, quality management, governance, integrity, architecture, ethics.
integrity, architecture, and ethics. And when you're finished, you'll have an
Stuff like data ethics, I'm not saying is unimportant, but it does not help you get a job.
understanding of the practices that organizations employ to make sure that their data can be trusted. All right, so that said, let's get started.
I'm saying if you put that on your resume, employers are gonna gag. Garbage in, garbage out. Accuracy, completeness, consistency, timeliness, validity, uniqueness, untrustworthy results, lost revenue, misunderstanding customers. This is so much more than just business intelligence. This is science as a whole. In the sports science field, it as well as the health science and beauty science fields and political science fields. This is just my take. I don't have data to support this, but a lot of the scientific research and scientific papers in them have invalid results. They might be using the wrong kinds of hypothesis tests or conducting them in pretty bad ways. And this is why, well, there's a lot more reasons as to why these things happen, like corruption, lack of education in the right areas, but it is very real. Next item, pillars of data quality management. Data profiling. Oh, also, I feel like this. Wait, why did they make data profiling the darkest cube? What? Okay. Data profiling. Quality measures, yep. Looking for values, formats, data, zip code, quality rules. Okay. NIP rules, know about that. Data repair. Data repair is just fixing faulty collection methods. Data enrichment. Incorporating outside data that is not directly related to your core data as a means to gain additional insight. Mark is completed. Data quality management. Okay. Data quality. One thing that I've noticed is my upload frequency may have lowered. And my videos might not be getting longer per se, but the amount of work and the quality of work I can do per video, I feel has definitely went up. For pretty much everything, maybe not programming, because I don't know. I guess it's like exercises in the gym. Sometimes you see everything moving except this one exercise, and sometimes you just have to wait. Your company has been collecting customer birthday data. Take a look at column C in the image below in regards to data quality management. What is problematic about the birthday data that has been collected? They are not formatted in the same date format. They don't have the same date format. While poor data quality can affect a business analyst's day-to-day work, unfortunately, it does not really have much impact on the business itself. This is false, because if the data quality is poor and you're a data-driven business, then your day-to-day decisions would be impacted by the poor quality of data. Clean quality. Oh my God, poor data. Profiling. That's the only cleaning rules. Oh my goodness. I've forgotten. Okay. Profiling quality rules. Cleaning. Repair and enrichment. Okay, that is what I was missing. Okay, introduction to data governance. What is data governance? Okay, well, I'm not reading the screen. I'm just, thinking about data governance. What does that sound like? It sounds similar to management, data management. Maybe it is the same. Maybe it's just a different word. But it sounds like overlooking your data and seeing if things are in order, because that's what the government does, right? Or what they're supposed to do anyways. That's what the governor does. Okay, so let's see. Refers to the high level of processes, policies, and standards that determine the way an organization uses its data. A good data governance strategy will define what data will be used for business purposes and establish clear roles and responsibilities for employees when it comes to data management. It defines who has access to what data, what they can do with that data, and what methods they might use. Okay. Some of the goals of a data governance framework include the following: defining what data is, creating rules for how the data is used internally, data accuracy, data standards, accountability, implementing mechanisms to track and measure overall data quality, promoting a wider understanding of data as an asset across the business. Okay. Data governance tutorial. Holy crap, Reno. I'm gonna get copyright claimed if I watch this video. Metadata, data scraping, data quality, data integrity. I don't. No, we'll skip this. Okay. Data governance versus data management. Okay, I did talk about this a while ago. Outlines the overall structure that should exist. It's more about what should happen and how things should happen. Why data governance matters means that the quality data is accessible to the right people in an efficient way. Means not having multiple databases that contain duplicate info. Data governance makes it really clear who has access to data, how much access they have, and what they are able to do with that information. Determine who is involved. Typically, there are multiple roles when it comes to implementing data governance, including data owners, analysts, champions, or subject matter experts. However, it's up to everyone, especially the business analysts, to be vigilant in governing data over the long term. Determine the scope. It's not practical to try to control all of your data from the start. It's important to prioritize the data. Stuttering, oh my god. It's important to prioritize the data you want to control based on business priorities. As you have the most important pieces in place, you can expand further and further. Document the available data. Look at what information is in the data and where it comes from. Identify who owns it, how frequently it's updated. Before defining any rules, it's important to understand how the data is being used right now. Data integrity is not just the overall quality, also refers to It also refers to the stability of your data, how well the accuracy, validity, and consistency of the data is maintained from the moment the data is created as you move it around your system. Data integrity often requires putting checks into place to ensure the finalized data matches the source data. It's not a do it once and forget about it thing. It must keep going. Okay. 3 pillars of data governance: people, processes, and technology. Obviously, people are the people who have to make the obviously they're the people who have to make the decisions. Data governance board, custodians, stewards, were the go-to resource for how data is collected. Processes. They ensure that all data is accurate and can be trusted. Developing rules for how data will be stored, moved, accessed, and protected. Auditoring and monitoring data quality, especially when it comes to regulatory compliance. This refers to the applications or tools. Yep, okay, so this is pretty obvious, right? People, literal people, individuals. Processes, what do you do? How do you develop the rules? How do you audit and monitor data quality? Then technology is the literal machinery and technology and softwares and whatnot used by the organization. Okay. What is data integrity? It's not just quality, but it makes it so that your data is valid, makes it so that your data is usable for analysis. When I say that, usable for analysis, if you try to conduct numeric mathematical operations on 5 different data points, and 4 of the data points are numbers, but then the 5th data point is a string, your software would explode. Not really explode, but it would be invalid. It wouldn't work. Your dashboards would be broken. Your dashboards wouldn't be displaying. They'd be erroring. So that is what data integrity is. You're trying to avoid these little dumb mistakes, silly mistakes just like this. It might not be the end of the world, but it could be. And it sure is annoying. And your boss would probably get pissed off if like it happened enough times. Okay, best practices for data integrity include access controls. So who can access? Include an audit trail. It's essentially history. It shows you who has modified the data when and what exactly did they do at the time. Backup data. Yep, in case anything happens, physical breach, technology failure, hardware failure, back up your data so that it's not the end of the world and your company doesn't die because of you. Validate the data. Again, going back to validation, when we're talking about data, validating your data just goes back to what I was talking about. Only allowing certain kinds of inputs, only allowing certain kinds of data, so that your dashboards and your analysis aren't hindered by these little obstacles. Small things go a long way. Data governance, okay. Where? $134. Oh, Crunch. Captain Crunch. Okay, start. Which of the following refers to the high-level processes, standards, burn? Okay. Governance. Because it allows for companies to approach, manage their data more efficiently and improve. I guess that's the answer. Again, what is it? So you have the freaking rules, the validation. It's the foundations of data governance is processes, people, and technology. Validation, integrity, and security, I guess. Explain the difference between data management and data governance. And is a day-to-day thing where data governance is all about what should be and what should happen. Technology, processes, people. Which of the following best describes data integrity? Rules. No, that's validation, actually. Assurance of overall accuracy, completeness. Yep. Let's see. How many are we gonna get? Nice. What is data architecture? Okay, quite a lot of words. Data governance board who make decisions about data usage in an organization. Okay. People, processes, technology, data governance. Okay. We've already talked about the stuff above here, so we don't have to read it again. Data architecture is the way in which data flows around an organization and the effort to control it using design models, rules, etc. One simple example might be data that is stored in a spreadsheet and is read into a business analytics tool like Tableau. Another more complex example might be data that is collected from multiple point of sale systems and then streamed through a data lake and data warehouse before being read into a business analytics tool like Tableau, where it can be analyzed. Okay. Point of sale systems. If you're unaware of what they are the machines at the grocery, by the checkout. There's a computer and they punch in what you've bought. They give you a receipt. These things collect data. Apart from point of sale systems, other pieces of technology that track a lot of data are things like your phone, your internet, your router, your gaming devices, video games, softwares, computers. A business analyst is responsible for adhering to the data structure, can collaborate. Yep. And a data architect thinks about these questions: how to move the point of sale data from the Costco to Costco headquarters, and how do we clean the data, extract, transform, load it into the warehouse. Components of data architecture. Okay. Data storage, data schema, data security, data movement. Okay. These are the components of data architecture: storage, schema, and types, security, data movement. Let's start with storage. How data will be stored. Will it be a physical storage? I mean, it's always physical. Is it on site or is it remote, cloud-based? Will it be relational or non-relational? These kinds of questions. Schema, types. When you collect data, typically, not typically, always pretty much, you have to have a schema within your database. If your data is structured, you collect it and you already have a schema which dictates the attributes and their types, such as numeric, string, float, certain number of digits or characters. Data security, encryption, roles, keeping data anonymous. Okay. Data movement. Data is collected in one place, moved to a staging area, and then moved again into a data warehouse. Every time you add a new source of data, you need to consider how to shift this data through the organization to get it to the right end users. Takes into account the data needs of an organization, provides means of achieving them using different protocols and tools. Data ethics. Okay, I'm not going to read that. I'm lazy. Data architecture practice assignment. Start. What is the difference between data governance and data architecture? Okay. What should happen with the data and how those things should happen. What should happen with the data and how those things should happen. Okay, so it's 1 or 4. I'm gonna go with A because it talks about data architecture being the technology and infrastructure that actually makes those things happen. 4 components of data architecture. I have already forgot. Let's... it's fine. Which of the following are commonly recognized principles of data ethics? Transparency, individual ownership, encryption, privacy. What policy requires organizations that collect data from citizens of the European Union to meet certain obligations for privacy? Ooh. I think it might be GDPR. Yeah. I remember seeing that a while ago. 4 components of data architecture. Okay. Say rules, policies. I'm just guessing at this point. This is probably not true. It's a flaw in the system. Can't blame me. Ah. Storage, schema type, security movement. I was totally off. Week 3 data recap. It's a bunch of this stuff. Okay, graded assignment, data management. Yep. Let's data management. 23, 10. In a comp, in a comp, in a company, in a, in a company, in a company, it is very uncommon for incorrect data to be collected false. Which of the following factors can impact the quality of your data? To be honest, all of them. Okay, let's go through why. Uniqueness. I don't actually remember what uniqueness meant in the context of collecting data, but I remember reading it. Accuracy definitely will affect it, you know. This is data. This is me collecting data. I haven't sworn yet this video, which is pretty amazing. Okay. Which of the following factors? Okay, so accuracy. If you are collecting temperature samples and you're only collecting whole numbers instead of floats, that would skew the quality of your data, right? So accuracy makes sense. Timeliness. If for some reason it's taking you an additional month to collect present data on sales, then your data is less relevant and you can't really pivot or react to your data as quickly as if it was on the same day or real time. Consistency, I believe that has to do with formats and mistakes and whatnot, so definitely will affect you. Which of the following are considered one of the pillars of data quality management? Okay, pillars, data quality management. Profiling, repair, rules, translation, enrichment. I don't remember those. Which of the four pillars of data quality management are you executing when you add these requirements? You notice a number of errors in the zip code field. For example, you see that a handful of zip codes have been entered with 6 digits instead of 5. You found a few that have been entered as 00000. Not a valid zip code. You decide to set some validation requirements. The zip code can only be 5 numbers in length. This is a data quality rules. Profiling enrichment, okay. A good data governance strategy will define what data will be used for business purposes and establish clear roles and responsibilities when it comes to data management. True. Why is data governance so important? Select all that apply. Because data governance makes it really clear who has access to data, how much access they have, what they're able to do. It means that quality data is accessible to the right people in an efficient way. Because the government requires that all companies have an approved, Which of the, oh, maybe. Oh, maybe. I'm not sure. Which of the following statements is true? Data governance and data management are simply different. Okay, data governance versus data management. Definitely not the first one. Governance outlines the overall data structure that should exist and that lays out what should happen with the data and how those things should happen, while data management is the day-to-day work that makes sure data governance is being followed. Overall, that should exist. Wait, what? Oh, okay. The first word changes. Governance. Yep. The 3 pillars of data governance are processes, technology, and laws or regulations. False. It's processes, people, and technology. Which of the following might be included as part of a company's data architecture? Select all that apply. Okay. Hmm. Okay, what is data architecture? It's technology involved, how data governance actually happens. Okay, so storage, software, rules, networks that move data. I'm skeptical about rules that determine who can access specific pieces of data, because that might have to do with data governance. But we'll go with it anyways. Your company has decided to create a new database for collecting information and leads. When the data architect set up the database, she implemented measures that require the contact name to be entered as a text value. The phone number as this, state as this. Which component of the data architecture do these measures represent? Data schema and types. Which of the following are commonly recognized principle of data ethics? Okay. Privacy, transparency, impact maybe. The other two are definitely wrong. I got encryption wrong, so I remember that's not an answer. Which of the following is an example of personable, identifiable information? Ooh. Credit card number, I guess. Maybe web browsing history because you have an IP address, but I don't think so. With a credit card number, you can go to the bank as the police and identify who owns that. Okay, we'll go through with that because we took our time to answer each question with some thought. 100% not sure, but pretty darn close. Ah, I knew it. This is, yeah. Next item. Haven't struggled too much on my final year at the Auckland University of Technology, majoring in data science and minoring business and data analytics for business. So just reading through this professional certificate. Course recap. We talked about data warehousing, database management, governance. So at the beginning of the video, we were talking about data ecosystem, different ways to store data, whatnot. We had 3 weeks in here. Yep. We talked about ETL. We talked about SQL. Yep. Easy money. Want to become a business intelligence analyst. Okay, and then it's just a bunch of fluff and filler. Graded assignment, data ecosystem, final assignment. Okay. 3 attempts every 8 hours. I thought that was the final assignment, but apparently it's not. Data ecosystem. System final. 152. What is tabular data? Table format. Which of the following is an example of software that typically contains tabular data? Spreadsheets, so Sheets and Excel. Have the ability to add, subtract, multiply. They use formulas. They allow users. These are examples of which of the following processes manipulating data. Which of the following are features that databases and spreadsheets have in common? Can store data in columns and rows. Have security features that can restrict access to specific columns of data or prevent individual users from deleting tables. Yep. So that it can be accessed at a later time. Yep. Pretty much all of this. I don't remember if this was wrong a while ago. I think it might have been, but I didn't really bring it up. So I will remove that because I think the point of this course is it's trying to tell you that databases are more secure than spreadsheets. So I won't select that, though I'm pretty sure spreadsheets, why wouldn't spreadsheets have security features? At least some, though not as rigorous as databases. Still, security features exist. Which of the following are distinctive features of a database management system? Okay. No. Yes. It's very fast. Data management, yep. Reliable data storage, yep. I mean, are they distinctive features? I suppose so. Okay. True or false? The biggest difference between a database management system and a relational database management system is the format of data that is allowed by the databases. Yeah. In a relational database management system, it's only tabular data. Whereas with just a regular one, non-relational, you can have documents, images, graphs, dashboards, reports. A local company has done a great job of collecting data. Each department has a database where they store information. As a business intelligence analyst, what is the best, most efficient way to analyze all of the data that has been collected? Okay. Warehouse, then analyze. Everything else is a bit slower, clunky. The purpose of a data warehouse is to analyze data from multiple sources, i.e. multiple databases. Which of the following is a key difference between a database and a data warehouse? Okay. A database typically contains data from a single application, whereas a data warehouse contains data from multiple sources. Makes sense. As I said earlier. Which of the following characteristics apply to a data warehouse and not to a database? Select all that apply. Historical data. Optimized for analysis purposes. Updated regularly is not true. Rarely updated. Optimized for analysis purposes. I believe so. In the ETL process, in which stage is data combined, filtered, sorted, summarized? Transform. Which type of data mart is created by segmenting an existing data warehouse? Dependent. What is the primary reason that a company would choose to utilize a data lake? Okay, I'm not looking at my screen. Raw data, flexibility, unsure of what they're going to do with the data just yet. Okay. Allows for the storage of all types of data. Yep. Which of the following features accurately describes a data lake? Native format, correct. Variety of formats. It's not processed. That's what makes it native format. True or false, the quality of your insights directly correlates to the quality of your data. Shouldn't it be the other way around? The quality of your data directly correlates. Correlates, not cause. Okay, so true. It's saying that your insights are impacted by how good your data quality is, so fair enough. Which of the following factors can impact the quality of your data? Timeliness, accuracy, consistency, all of them pretty much. Which of the 4 pillars of data quality management involves reviewing existing data in comparison to a set of quality measures? Data profiling. Yeah, comparison, yep. Which of the 4 pillars of data quality management involves identifying the root cause of data quality issues? Repair. This is saying the same thing as earlier, so this guy added a rule so that you have to put a certain number of digits for zip codes and it cannot be 00000. So quality rules. And then this is a question about management versus governance. Management talks about governance talks about what the data structure okay, let me just read the question. Data governance outlines the overall data structure that should exist and what should happen. Data management is the day-to-day work that makes sure data governance is being followed. Yep. Which of the following are considered to be components of data architecture? Select all that apply. Oh yeah, so storage, movement, monitoring, regulations. Oh crap. Okay, so it's governance versus architecture, right? I think security, regulations, schema, and types, those are governance things. So we're just gonna pop through here and see how we do. it doesn't look like we passed because the thing at the bottom left. Oh, no, we did. Darn it. Oh well. Course wrap up. Course 3 wrap up. Time check. 2 hours exactly. Nice.
Congratulations on finishing the third course in the Tableau Business Intelligence
Yeah. Data ecosystem.
certificate, data ecosystem. You're now one step closer to becoming a business intelligence analyst. At this point, you have a lot of foundational knowledge in business analytics. In the next course, you'll start getting a lot more hands-on experience working directly in Tableau, one of the most popular data visualization tools in the industry. I hope to see you there. Take care.
Yes! I almost screamed and ripped out my vocal cords. Quite sore, a bit scary, but that was course 3 out of course something. Let's see. Okay. How do I see where my thingy is? Modules? My purchases? Where is my... Up next in Tableau Business Intelligence Analyst Specialization. Okay. Show 3 more. I can't see... Oh, okay. So we done business analytics, we done data ecosystem, we talked about... Is it this? We just finished data ecosystem. Introduction to business analytics. How do I know where to go? This is my only gripe. Whenever I finish a course, I don't know what's next. I wish I just like threw you into the next one. Okay. There you go. Introduction to Tableau. Okay. But I will leave it here because we've hit the 2-hour mark. Also, we just finished the certificate 3. Module 1, 2, and 3. Welcome to the course. So we're actually going to get started using Tableau in the next video, which I'm pretty excited for. I like learning how to use things. I think hands-on experience is like really fun and really useful because at the end of the day, that's ultimately why you're doing it. I'm pretty excited to be able to integrate my statistics background with business intelligence tools and data ETL tools like SQL and database management systems. Okay. I've only said like 11 times and I've only said 9 times. So hopefully in the next one, we do better and say them less. I didn't really come across too many hard words this video. But yeah, thank you for watching. That was Data Science Sessions episode 5. I'm starting to enjoy the series more and more. I remember the first episode I shot this, I didn't realize how much reading I was going to do. I didn't really plan ahead of time. I just kind of did. Because with a course like this, there's just so much text, so much theory. We're 5 episodes in, we haven't even touched Tableau yet. But still I want to talk through and try and entertain you guys all the while reinforce what I'm learning, what I'm reading. So if you like the video, hit subscribe, leave a comment, talk about yourself. What do you do in your spare time? And yeah, I'll respond to them as fast as I can. But anyways, I will see you in the next video tomorrow. It might be speedrunning math or a coding video. Can't remember. Anyways, have a good night, fellas.